Hey everyone, welcome to the National Pesticide Applicator Core prep course. I have wanted to make this for quite some time. Um, this is a side project for me to help people. I really wanted to create something that helps people get into this industry because there's a lot of opportunity in this industry. And from what I know is that the actual National Pesticide Core test has about a 70% fail rate. And so this is basically a cheat code, a hack to get the information that you really need to know out of this book. Okay. This book right here. Oh, green screen's affecting it. But this is the National Pesticide Core Manual. And there's a lot of information in it. It's like 168 pages. And I wanted to create this so that way, if you're studying to renew your license, or if you're new and you want to get into this and reading that book is just way too hard, you don't want to sit down and read. Now you have a presentation that you can go to, watch, learn some key terms, learn what you need to know to pass. And then what I'm also going to do is I'm going to take these slides and I'm going to turn them into a document that you can do like a quick study sheet, as well as turn this into audio. So if you want to just listen to drive in some terms and phrases and knowledge, you'll have video, you'll have physical copies, and then you'll also have the audio. So you're going to have everything that you need to learn in whatever way that you learn best, right? So real quick, I didn't introduce myself. My name's Austin Douglas. I'm the owner of Elevate Applicate and Ditch the Itch poison ivy and mosquito control services over here in Michigan. I'm a certified arborist, tree risk assessment qualified. Got a couple other credentials, and I am passionate about this industry. I love this industry. I've been doing this for about 10 years. So I own a pesticide applicator business, and I've taken these exams. I've studied a lot of books, a lot of information, and so I really just wanted to create this for you. Okay, for you or maybe people within your company. That's the goal of Elevate Applicators, to enhance green industry professionals. So without further ado, let's get into it. So this is going to be chapter 1. Okay, and I'm actually going to put I'll keep myself right here for now. So this is the prep course. I've gone through the book and basically found everything that you need to know throughout the chapters. Actually, I'm going to come down here. And basically, we're going to dive into the information that you need in order to pass the exam or your renewal, or if you just want to refresh your memory. Okay, all of that is available to you. So like I said, here's some of my credentials. I'm mainly in plant healthcare. I mainly do herbicide applications, insecticide applications, fungicide applications, some tree growth regulator applications. I'm certified in right-of-way, mosquitoes, ornamentals, turf, and then obviously the core. So I've got a pretty good understanding of the industry. I haven't done internal applications. I've never gone inside structures and performed applications. I've never treated general pests because over here in Michigan, that's a separate license. So without further ado, let's dive in. So Pest Management, Chapter 1. Nice, lovely little mosquito hanging out there. Disease transmitting bastards that they are. So the history of pests. Basically, we had the Black Plague back in the 14th century. Come to find out that it was a bacteria, and that's why people were dying from it. This is basically just a brief history of pests that have affected humankind, and guaranteed that there will be questions on the exam regarding one of these. We had the Irish potato famine, which was a fungal disease of potatoes. Really, it starved a lot of people in Ireland, in Europe, and a lot of people from Ireland came over here. That's why Boston is such a big area for the Irish. Then we had malaria as another one, which in World War II, 500,000 soldiers were infected, 60,000 died, and in 2010, the data showed that there was 219 million cases of malaria globally. So it's not something that's gone away. It's pretty prevalent even to this day. It has, I think the numbers have steadily decreased because we've learned about malaria and mosquitoes. We've learned that adding mosquito nets, if you live in a malaria-prone area, can help. Also, insecticide treatments. Actually, now they make mosquito nets. They're enhanced with insecticide in them. So if a mosquito hits the net, they hit the net and then they die. We also had the native mountain pine beetle, which was something that affected the United States and Canada. And it destroyed over 4 million acres of pines. You can imagine that's a pretty substantial loss. The book didn't list this one, but there was another one. There was the American chestnut was affected by a fungal disease that came over off of Chinese chestnut trees. And they named it and dubbed it the chestnut blight. And the chestnut blight wiped out, I think, about 4 billion American chestnuts. So even though they listed the native, mountain pine beetle, that probably was not the most devastating across the United States. But pests have always been around since the beginning of human civilization. What is a pest? Well, we kind of need to know that if we're going to be pesticide applicators, right? It's an undesirable organism that injures humans, desirable plants, animals, manufactured goods, or natural substances. And we've been trying to control pests for a very long time. Some rudimentary controls that we've done in the past and probably still do to this day would be pulling weeds. How many of you pulled weeds out of your garden? I know I have, still do. It works. Killing of animals. So if you got mice or maybe have deer eating crops, you're going to take those out so they stop affecting your crops. Burning plants, which the Native Americans used to do that pretty frequently here. And that would basically kill a bunch of insects or, any sort of pests. The Egyptians, they used to use fish nets over crops to prevent mosquito bites. That was in 440 BC. The Romans used to use rat-proof grain storage, which I thought was pretty interesting. They realized they had a problem, and so they made, sealed storage for their grain. And then the earliest chemical control that was recorded was the Sumerians. The Sumerians used to use sulfur to control mites and insects, and that was 2500 BC. Additionally, more pest control throughout history. The Chinese, they used to use mercury and arsenic. They used that mainly on lice. We also had early plant-derived controls like hellebore, nicotiana, and chrysanthemum. And basically, those are natural products that have substances in them that kill insects. Like chrysanthemum, that's where pyrethrins come from. And basically now synthetic pyrethroids are derived from that chemical of that plant. Now they're just made in labs. But nicotiana is tobacco, and they use that for aphids. Ironically enough, the use of tobacco has also caused tobacco mosaic virus on some plants. So it's a good thing to a certain extent. And then, it can actually cause damage. In France, farmers used to use lime and copper sulfate on their grapes. And originally, they did that to deter people, which people can be considered pests at a point, right? If they're going to damage your crops. And then they realized that it treated downy mildew. And now it's still a widely used treatment even to this day. So from that far back in history, something that's worked is still working. There's no resistance showing for that. So that's cool. World War II, DDT saved thousands of lives from insect diseases, beginning of modern chemical pesticides. Once we developed DDT and we gave it to our soldiers, they weren't getting bit up. They weren't getting the diseases like they were. And now it's like, okay, maybe we should invest in some chemicals. What is a pesticide? It's any material that is applied to plants, soil, water, crops, structures, clothing, and furnishings. It's also anything that's used to kill, attract, or repel animals, regulate the growth or interrupting of mating of pests, and also plant growth regulators. Pest method controls. So we have chemical control, probably the most used method to date, synthetic or naturally derived. It's very cost effective to use a chemical control for the most part, generally more cost effective than having to do something physical. They're very, easy to use, relatively speaking, and they can be mass manufactured. When they do mass manufacturing, they can maintain a certain threshold of the quality of the product. So it's a very common method. It's why we're studying for this exam and why we need to know this information, because that's what we probably intend to use. Pest control methods, chemical control. So we have avicides, which is to kill or control birds. We have bactericides, which is to control bacteria. Chemosterilants, which is used to sterilize insects or vertebrae. Defoliants, which means it's basically just going to take the foliage off of plants, going to cause the plants to release their foliage. Desiccants, you're causing a drying out effect of plant tissues and plant material. Disinfectants, we know that. We have had to deal with disinfectants for quite some time in the previous years. Fungicides kill fungi. Growth regulators for fruit production to slow growth or uncontrolled growth, which would be herbicides. Most herbicides are actually growth regulators, but they're different. They encourage plants to grow extremely fast, so fast that they can't keep up with their food storage. So they end up starving, which would go into herbicides, but I also put it in growth regulators because, that's kind of what they are. But herbicides control plants, insecticides control insects. And then we have some more. We have miticides, control mites. Molluscicides control snails. Nematicides, nematodes. Repellents, which I'm sure most of you have probably used some sort of insect repellent in your life, more than likely for mosquitoes, ticks, flies. But there's a lot of different repellents. You can control deer with repellents, other various animals. We have ovicides, which kill eggs, pheromones, which attract insects. So we might use pheromones to pull insects or animals into certain traps or into certain areas. Predaticides, predator vertebrae, trying to get rid of them. Think of like coyotes. And then rodenticides, taking care of rodents, right? Mice, rats, things like that. Chemical control, how do they work? So they have modes of action, and every chemical has a type of mode of action, and some have multiple types of modes of action. Site of action is a specific biological component that is affected by the chemical. So what's being affected? Is it the nervous system? Is it the ability to produce food in the sense of an herbicide? What is it? But that's the site of action. And then we also have selective and non-selective chemicals. Okay, selective are toxic to some pests, but not all pests. They can have very little effect on others. So I want you to think of turf grass applications. You can apply herbicides that are designed to kill broadleaf weeds on grasses, and those are selective. They're going to get rid of the broadleaf weeds, but they're going to leave the grass. Think of 2,4-D or triclopyr. And then we have non-selective. Think glyphosate, right? It's a kill-all. It controls any susceptible organism to that chemical. Bifenthrin would be non-selective. That's an insecticide, and that's a broad-spectrum insecticide. You can kill various different insects with that. So just some examples. We also have systemic and contact. Systemic is absorbed and translocated through animals or plants. Contact is not absorbed. It's direct contact to be effective. So wherever you apply that product is what it's going to damage. It can be eaten or injected. I'm sorry, that's the systemic. Systemics can be eaten or injected. So sometimes our dogs will actually get some flea medication and they ingest it through a pill, and then it becomes systemic in their bodies, and then they're less susceptible to fleas and ticks. Persistence. Okay, so now we're getting into some terms that you should really understand. Persistence is how long the chemical remains active to control the desired pests, and it can vary greatly. Some pesticides are completely gone in a couple of hours. They degrade that fast, while some can last, years. Residual pesticides, they control pests for weeks, months, years. Some have minimum residual or short-term control, which only last a few hours. Cultural controls. Okay, so we're talking about application methods here and types of control. Cultural controls are practices that reduce pest establishment, reproduction, dispersal, and survival. Examples would be mowing, irrigation, fertilization in terms of the landscape or lawn aspect. In terms of agriculture, you would have selection of crop varieties, timing of planting, timing of harvest, irrigation management, crop rotation, trap crops, microorganisms, and plow discs. All these things are cultural controls for controlling pests. Sanitation is another big cultural control, eliminating the food sources, the habitat, the water. So I put draining standing water on this slide, and that's mainly because I wanted you to think something of like mosquitoes. Mosquitoes breed in standing water. And so if we can get rid of the standing water, undoubtedly, we're going to reduce the amount of breeding mosquitoes in the area. Genetic controls, right? We have selective breeding resistant to specific pest problems. Think apple scab, Dutch elm disease, oak wilt. Right now, they're breeding crabapple trees to be less susceptible to apple scab. Now, it's different in an orchard. They actually encourage apple scab. And why they encourage apple scab is because it produces stress on the tree, which then causes the tree to produce sweeter fruit. Dutch elm disease, we have more resistant elms. And oak wilt, they're trying to breed red oaks to be less susceptible to oak wilt. We also have other genetic controls like soybeans and corn that are Roundup ready. They can withstand that chemical. They're designed not to be affected by it. So that's, some GMO stuff, but it's doing its thing. Mechanical and physical controls can kill pests directly. Think rodent traps, right? A mouse walks into a mouse trap, it snaps its neck, and it's done. You have sticky traps, which are going to be mainly used in agricultural purposes. You might use them in a landscape purpose. The number one area that I've seen these used is greenhouses, and they're really to monitor. But you can use traps, and you can reduce the pests that are there. Mulching, deer fences, and mesh screens. So those are all examples of physical or mechanical control. And then we have regulatory control. Regulatory control are government mandates like quarantines. Think boxwoods or spotted lanternfly. Boxwoods here in Michigan have been in a quarantine because of box tree moth as well as boxwood blight. So they're not allowing the transportation of various materials. Same thing with spotted lanternfly. Michigan last year was just introduced. We just had spotted lanternfly introduced. We just found it. And what we did is basically quarantine the area and started treating and scouting everywhere. And that's what the government did. And then also nursery stock, right? How do we control nursery stock, or what's happening with nursery stock? Well, Bradford pears kind of got out of control, and Ohio decided to ban them. So they're no longer for sale, transport, anything like that. So that's some examples of some regulatory control. Integrated pest management. This is a very key word that you need to know. The concept of using multiple methods of control, right? You're going to mix chemical and biological and cultural controls together. You're going to adjust timings, things like that. But you want to use a balanced method to achieve your objective. Minimizing chemical usage through proper timing and rates, right? When do you use chemicals? When do you do insecticide treatments? When should you? Well, if you look at growing degree days, or otherwise known as GDD, that will tell you the best time or when you need to. Because why would you apply an insecticide out there in the world if the insects haven't even emerged yet? Or what state in breeding are they? So there's a lot of data out there that can help you and increase your professionalism and reduce your pesticide usage. But it's a balanced and tactical approach to achieve control. Prevent pests from reaching economically or aesthetically damaging levels with the least risk to the environment. That's the goal of an integrated pest management plan. The components of IPM are identify the pest and understand its biology, monitor the target pest, develop the pest management goal, implement the integrated pest management program, record and evaluate results. And all of these are critical to an IPM program. Identifying the pest and understanding its biology. Determine its significance and need for control. Some pests might not really need to be controlled, while others might need extensive control. You need to know what key pests are. What are they doing? Key pests are generally something that's going to cause significant damage. And then what are secondary pests? Secondary pests are generally pests that emerge after the key pest comes in and does its work. So because the plant is already susceptible, now you have additional attacks coming at it. And then we have occasional pests, right? We have waves like gypsy moth, or I think it's called spongy moth now. Those come in waves. They'll be around for a couple of years and then they'll kind of subside. So we just have to be paying attention to that. Monitoring the target pest. So scouting and trapping over time, weather and temperature data, GDD, growing degree days, economic thresholds, the justification for control due to loss of quality or quantity of a crop, economic injury, pest population density that causes loss equal to the cost of control measures, action thresholds, the level at which some type of pest management action must be taken. So these are all really critical, right? Economic injury level, at what point is it just a wash? What's the economic threshold level? At what point do you justify control or the loss? Then the action threshold, at what point do you absolutely have to take control? Develop pest management goal. There's really 3 goals of pest management. There's prevention, suppression, and eradication. Prevention is preventing loss or damage from pests. Think pre-emergent herbicides, mulching, selecting resistant varieties. Suppression, which is mainly what we do out there in the field, is reducing pest population to an acceptable level, basically to where our clients are happy, our fields are happy, our plants are happy, what's acceptable out there. And that's determined by the client, not you. And then we have eradication, which is effective in small areas and indoors, but really ineffective in larger areas. And I put up here, think emerald ash borer, because that was something that's relatively large spanning insect damage. And it's still spreading. It's still going into states where it's never been before. So eradication of that is pretty much non-existent. Implement the integrated pest management program, right? This is number 4. Selection of appropriate methods. So are you going to use cultural methods, chemical methods, biological methods? You probably don't have any way to determine regulatory methods. Predetermine the thresholds. This is a conversation between you and the client. What is an acceptable threshold? And programs are specific to each situation. So it's not going to be a one-size-fits-all program between, client A and client B. It's going to be something that's very specific to their property, to their needs, and also based on their threshold. And then you also need to observe all local, state, and federal regulations regarding methods chosen. And then record and evaluate results. Extremely important to record and evaluate. Some methods are slow yielding. Other methods may be completely ineffective or damage the target crop. Objectively evaluate how well your strategies are working so you can better your strategy for the next time you encounter the pest. These are all reasons why you should record and evaluate your results, just to see, just to know. Because if you have this data, now you can make a better plan in the future, and that's going to yield you better results, right? Effectiveness of pest management programs. Pest identification. How can you have an effective program if you misidentify the pest? You really can't, right? Because if you're applying for a certain type of insect, but it's a completely different type of insect, but you chose an insecticide that only treated for the type that you thought it was, well, you're going to have poor results. So you really need to know and identify your pest. You also need to use correct dosages of pesticides. Too little may not provide the desired results, and it can cause resistance. And if you start to cause resistance, now you're making your job a lot more difficult, and you're not really assisting your clients. Correct use of pesticides. So products used for their purpose, selective versus non-selective, systemic versus contact. What one do you need for the purpose? And you have to pick the correct one. Effectiveness of pest management programs continued. Application timing. If the pest is dormant, it is probably a bad time to treat. Figure out when the pest is most vulnerable. Going back to growing degree days, there's a lot of data and information out there on growing degree days. And you can generally find that at universities, and that will help you determine when you should be out there scouting and treating for certain pests versus nilly-willy spraying everywhere. You also want to use the right equipment. A handheld 2-gallon sprayer is not ideal for spraying a 40-foot tree, right? You need to have the proper equipment. And then environmental conditions. So you're not going to go out there spraying in the middle of a downpour. It's just not ideal. You really need to understand what you're doing. Is it super windy? Is it raining? Is it going to rain? How much time does my product need to dry? All that type of stuff. Pesticide degradation, issues with storage. Are you storing it out in the sun on a pallet? Well, your pesticide's probably going to degrade pretty quickly. So you need to have a quality storage area. Pesticide resistance. So on this slide, if you're watching, I actually put the picture that's in the National Core Manual to demonstrate resistance and how it occurs. I would encourage you to watch this and look at that. But if you're listening, we can kind of go through it. What is pesticide resistance? It's the ability of a pest to tolerate a pesticide that once controlled it. It develops when intensive pesticide use kills the susceptible individuals in a population, but leaves resistant individuals to reproduce. So the resistance is passed on through new insects being born. Causing higher label rates to be used. That's a side effect of resistance. And causing more frequent applications. So you have to go out there more frequently. You're using more pesticides when you cause resistance, which is not what we want to do. Eventually, the chemical will have no effect on the pest, which now that's not good. So now you have to switch methods. You have to switch mode of actions. It's better to not cause a resistance. You can reduce resistance through proper rates and also change up your mode of action. So in my personal business, what we do is we apply an insecticide and a growth regulator. They both have two very different modes of action, and the two in combination will likely not cause a resistance because we're changing up the mode of action. So that's just something to think about. And that is what I have for chapter 1. So I hope you got something out of that. Like I said, this is going to be available in print form, so you can actually see these slides laid out, as well as the audio version. I'm going to extract this from this video, and I'm going to make an audio version. So that way you can listen to it, drive in some topics, make it easier for you, right? Like I said, there's about a 70% fail rate of the National Pesticide Core Manual, which is not very good. So that's chapter 1. Welcome to Elevate Applicate. Welcome to the National Core Prep course. I hope you got something out of it, and I will see you guys in the next chapter. Take care.